Okay, everyone. In this video, we're going to solve some division problems. And we have 3 learning objectives. And as you can see here, first, we are going to do some divisions using whole numbers. Then we solve equations that has unknown factor in it. Then we're going to solve some application problems using division. Let's look at our first objective, dividing whole numbers. Now, we have example 20 divided by 5 equals 4. First, the number in the division, the first number in the division is called dividend. The second number is called divisor, and the result of the division is called quotient. This is just some terminologies. Now let's look at the meaning of division. Say when we learn something, we want to know the meaning of it, not just pure calculation, right? So 20 divided by 5 equals 4. What does this mean? There are 2 different meanings, at least maybe more than that, depending on the context. First, we can divide 20 into 5 equal parts, and 4 is how much in each part. So in other words, the first meaning is that we divide the first number into 5 equal parts, and the result is the amount for each part. For example, if we split $20 among 5 people evenly, how many dollars each person get? So each person will get $4. So that's the first meaning of division. Second meaning is that this will give you how many, division will show you how many of the second number are in the first number. So 20 divided by 5 equals 4. It means there are 4 5s in the first number. It's like the first number contains 4 of the second number containing. So how many of the second number are in the first number? Now, there are several different ways to indicate division, this operation. First, we can use a slash to indicate the division operation, or we can use a fraction bar. Actually, this fraction bar is also being called division bar. That's why it means division. And finally, we can use this long division format to indicate division operation. You put the dividend, which is the first number inside, and the divisor outside, and the quotient will be on the top. Now, move on to the property of division. And we learned properties of addition and properties of multiplication in the previous videos. Now, let's look at the properties of division in this video. Now, we know we have commutative property of multiplication, which means the order in the multiplication doesn't matter. For example, 3 times 5 versus 5 times 3, they all give you the same answer, which is 15, right? So order doesn't matter. Commutative means you can change the order of those numbers in your operation without changing the result. And this is not the case for division. 20 divided by 5, certainly it will not be equal to 5 divided by 20, right? So we don't have commutative property for division. This is also true for associative property. So we don't have associative property for division. Associative property means, and you can do the first operation first, or you can do the second operation first without changing the result. And that is true for multiplication. Let's take a example, just illustrate. There is an associative property for multiplication. Let's say 5 times 2 times 3. So we can do first operation first, which will give us 10 times 3, then final answer is 30. Or we can associate these two together. In other words, we can do the second operation first and then do the first one. Say 5 times 2 times 3. The way we indicate we do the first one first, first operation first is by using a parenthesis. And if we do the second operation first, it goes like this: 5 times 6. You still get 30. See, it doesn't matter which operation you do first, the result is the same. Now, this is not the case for division. If we do the first operation first, 32 divided by 8, that's 4. Then 4 divided by 2, that's going to be 2. But if you do the second division first by associating these two numbers together, they get 32 divided by 4, which is 8. So the result is totally different. That means we don't have associative property for division. Okay, now let's move on and take a look at other division properties. The first one, when any number is divided by 1, the quotient is the number itself, the dividend, the first number. Now, in terms of mathematics language, it goes like this. N is any number. So n divided by 1, which can be also written as n on the top, 1 on the bottom. The result is n, is the dividend itself. So for example, if I use these two numbers to demonstrate 5 over 1, 5 divided by 1 equals 5. And this totally makes sense, right? So remember the meaning of division at the very beginning we mentioned. When you do division, it means how many of the second number are in the first number. So how many ones are in 5? Sure, we have 5 of those. How many ones in 10? We have 10 of those. That's why when you use a number divided by 1, you always get the result that is the first number. Next property of division. What if a number is divided by 0? That's a very interesting question, right? Now, let's explain this dividing by 0 by looking at this two. And sometimes people make a mistake by thinking that these two are the same thing. Actually, they are not, if we look at the meaning of it, of division, this operation. So 0 divided by 5, let's look at that one first. Again, this means 0 divided by 5. So remember the meaning of division. It means how many, if we divide 0 into 5 equal parts, how many is 1 part? That's one of the division meaning, right? So 0 divided into 5 equal parts, how much is in 1 part? What is the amount of 1 part? Which is still 0. No matter how many parts you divide 0 into, you still get 0, right? So this one actually makes sense. We have an answer. 0 divided by 5 is 0. How about the other one? 5 over 0, which means 5 divided by 0, which in terms of meaning means you divide by 5 among into 0 equal parts. You divide by 5 into 0 parts. What is a 0 part in the first place? There's no meaning in there. There's no 0 part thing in the whole world, right? That's why this one cannot be done, because it doesn't have meaning in this division. So we call it undefined. There's no meaning in it. So that's the answer. See, these two are totally different. Now, next topic we are going to look at is divisibility test. Sometimes given a number, we want to know which number can divide into that given number. So this is called divisibility test or divisibility rules, either way. The first one we are looking at is what number that can be divided by 2. Usually when people learn this in school, teacher will say even numbers, all of the even numbers can be divided by 2. So the answer is even numbers. What are the even numbers? Even numbers are those ending with either 0 or 2 or 4 or 6 or 8. If you have number ending with one of these digits, it's an even number, and that number can be divided by 2. But we want to dig a little bit deeper into this, why even numbers can be divided by 2. After we understand the reason, we can do something similar to these two rules. We understand them all. They follow the same logic, basically. The reason even numbers can be divided by 2 is that all of those even numbers are multiples of 2. And take an example. Say we have, let's say 16. 16 is an even number. And 16 is a multiple of 2. How do we do that? We just divide it by 2. 16 divided by 2 is 8. So we can write this division as 16 divided by 2 equal to 8. There are 8 2's in 16. We divided it evenly. So what is 8? 8 is a multiple. How many 2's in 16? 8 of them. 8 multiples of 2. So that's why, that's why even numbers can be divided by 2, because all even numbers are multiples of 2. And by the same logic, we can answer the other two questions. We can figure out the other rules by ourselves, basically. So the second one is, what numbers can be divided by 5? If multiples of 2 can be divided by 2, since even numbers are all multiples of 2, if multiples of 2 can be divided by 2, how about multiples of 5? Yeah, naturally, multiples of 5 can be divided by 5. For example, 15 is a multiple of 5 because you know there are 3 5's in 15. Certainly can be divided by 5. The result is multiple itself. But by saying multiple of 5 can be divided by 5, it's not that easy for people to remember that or to understand that, because you have to know, you have to have a way to identify those numbers easily. So instead of saying multiple of 5 can be divided by 5, you can tell people that numbers, we can say it this way, numbers ending with either 0 or 5 can be divided by 5. Why? Because all of the multiples of 5 ending either with 0 or 5. That's a way, that's a just different way to say multiples of 5. So for example, say, how about, say, 135? This ending with 5. Can this number be divided by 5 evenly? Let's try it, right? Divided by 5. And when we do division, by the way, this really means how many 5's are in this number 135. When we actually do this long division, we look at the digits inside this division symbol one by one. Is there a 5 in 1? No, there's no 5 in 1. That's why you don't put anything above 1. Now move another digit to the right, 13. How many 5's are in 13? We have 2 5's. That's why we put 2 above 3. Because only after you have digit 3, you have 13 that has 2 5's in it. So 2 times 5 is 10. Remainder is 3. Put down this digit 5 and repeat this process. How many 5's in 35? There are 7 of them. Now remainder is 0, we divide it evenly. So there are 27 5's in 135. So 135 can be divided by 5 evenly because it's ending with 5. So any number whose last digit is 0 or 5 can be divided by 5. Now the last one, what numbers can be divided by 3? Again, same logic. Multiples of 3 can be divided by 3 because when you divide by 3, the result is multiple itself. So how do we identify a number to be a multiple of 3? So this one is a little bit different, but logic is the same. And if it goes like this, if the sum of the digits in that number, in the given number, if the sum of digits can be divided by 3, then the number itself can be divided by 3. This is just another way to say the multiples of 3. Okay. Let's take an example to demonstrate this. Say I have 4, 0. I just try to create an example on the fly. 1011. Can this number be divisible by 3? Yes. The reason we add these digits together. 4 plus 0 plus 1 plus 1, that's a 6. That's a sum of the digits, which is 6. 6 can be divided by 3. So this number itself can be divided by 3. So let's try that. Maybe I don't have enough room here. Let's try it on the side here. 4011 and divided by 3. So first digit is 4. There's only 1 3 in 4. So we have 1 up here. And remainder is 1. Put down 1 digit, 10. 3 is in 10. So there's 3 in here. 3 times 3 is 9. And we have 1 remainder again. The next digit is 11. The next digit is 1, make it 11. So we still have 3 3's in it. 3 times 3 is 9. Remainder is 2. Put another digit 1. That's 21. There are 7 3's in 21. And we divide it evenly. Remainder is 0, right? Remainder is 0. We divide it evenly. So there are 1,337 3's in 4011. So this number, 4011, can be divided by 3. So that's the divisibility rules. Okay, let's move on to the next page. Look at a couple of examples here. Use divisibility rules to determine whether the given number is divisible by 2. So it's about the divisible by 2. We know all of the even numbers can be divided by 2, and all of those even numbers are ending with those even number digits, like 0, 2, 4, 6, 8, right? So apparently this is our answer, because this one, the last digit is 4, it's an even digit. So the answer is yes. This is not divisible by 2. Now, example 3. Use divisibility rules to determine whether the given number is divisible by 3. So we need to consider the rules for the divisibility test for 3. So we know if the sum of the digits can be divided by 3, then the number itself can be divided by 3. So we need to add those digits together. Let's do this one by one. 7 plus 6, 13, 17, 18, 21. So 21 can be divided by 3, and this number should be able to divisible by 3. So let's just double check using calculator quickly. 7, 6, 4, 1, 3 divided by 3. So we get a whole number. That means it's divisible by 3. So this is the correct answer. How about this one? 4 plus 2 is 6. 6 plus 5, 11. 11 plus 6, 17. The sum is 17. And the 17 cannot be divided by 3. So this one is not the answer. This one cannot be divided by 3. So this is our correct answer. The last one for the divisibility test. Use divisibility rules to determine whether the given number is divisible by 5. we know all of the multiples of 5 can be divided by 5, and all of those multiple 5 will have the last digit either 0 or 5. So that's easy to make decision. This one is not 0, the last digit, which is not 5 either. So this one is not the answer. And this second number, B, is ending with 0. So this is a multiple of 5, and this number can be divided by 5. So this is our answer. So once you know those divisibility rules, it's very easy to tell. Now you get the first exercise problem. Again, the answer is in the comment area and below the video. And actually you have 2 exercise problems. Now let's look at next topic. It's called long division. So everybody can use a calculator to get a result quickly these days, but we want to do it manually at the beginning when we learn it to make sure everybody understand how things work, right? That is more important in learning, not just getting the result. Now let's do that. Long division, the first number is called dividend. The second number is called divisor. We put dividend inside this symbol, 325. And we put divisor outside. Then we perform this long division process by looking at the dividend digit by digit from the left to the right, digit by digit. So first digit is 3. Then we ask ourselves this question, how many 5s are in 3? Remember, division meaning is how many of the divisors, the number, are in the dividend. So how many 5s in 3? So there's no 5 in 3. That's why we don't put anything here, even though it's 0. Usually for the whole number, we don't put 0 in the front. So we don't put anything up here above 3. Then we move 1 more digit to the right. We get 32 now. How many 5s are in 32? There are 6 of them, because 6 times 5 is 30, right? So put 6 above 2. 5, next step, multiply this quotient by the divisor and put it underneath these two digits. And then do subtraction to get the remainder. So that's a 30. Remainder is 2. Remainder is always smaller than the divisor. Otherwise, this number is not accurate. It's not right. So we put down another digit. And repeat this process. We ask ourselves how many 5s are in this number. It happens to be 25. There are 5 of those. So 5 times 25, 5 times 5, I mean, the result is 25. So remainder is 0. When remainder is 0, we call it divided evenly. So there are exactly 65 5s in 325. So this equals 65. There are 65 5s in 325. Or you can also say, interpret it as, if you divide 325, this number, into 5 equal parts, then each part has an amount of 65. And let's look at one more example for the demonstration of this long division. And this is a big number. I guess I'm going to do it on the side here so that I have more room. More room here. 42,017 divided by 41. Divided by 41. First, there's no 41 in 4. We move digit to the right. 42. Now we have 141 in 42. So put 1 above 2. 41. Do subtraction, we get 1 as a remainder. Now we put one more digit down. Do we have 41 in, how many 41s are in 10? We don't have any. We have 0 41s in 10. That's why you put 0 above this digit. Now we move 1 more digit down here. And how many 41s in 101? There are 2 of those, because 3 will give you 120 something. It's too big. So we're going to have 2 here. 2 times 41 is 82. So do subtraction to get the remainder. We need to borrow. So 11 minus 9, minus 2, that's 9, 9 is the answer. And after we borrow this, become 9. So 9 minus 8 is 1. So 101 minus 82 is 19. Now, put down another digit, which is 7, the last digit. How many 41s are in 197? We can do a quick estimation. If we multiply by 5, it's going to be 200. If we multiply by 4, it's 160 something. That's just about right. So this is going to be 4. 1 times 4 is 4. 4 times 4 is 16. Do the subtraction to get remainder. This is 3, and this is also 3. So you see, remainder is smaller than the divisor. Otherwise, your quotient is wrong. So we don't have more digits to go with. That means this is our final answer. But this time we don't have the division. We don't divide 41 evenly. We have remainder. Now, how do we write the answer if we have remainder? It goes like this. First, you write the quotient, 1024. Then you leave a little bit space here. You use the letter R. Sometimes people use a capital letter. Sometimes people use a lowercase letter. Either way is okay. Then you followed by this remainder. So that's how you write the answer. But by the way, how do you check if this answer is correct? If this is correct, then this quotient multiplied by the divisor, then add to this remainder will give you the original number. So let's do that. This is how you check. We use a quotient because this really means you have 1024 41s in this number plus some remainder. That's why we multiply these two together first, and plus a little bit extra, we call it a remainder. And this should give us exactly this number if my answer is correct. So I am going to use calculator just to speed up this process. And 1024 times 41 plus 33. What do we got? 42,017. 42,017. That means our answer is correct. 42,017. So checked. This answer is correct. Now you have your own exercise. Our next topic is going to solve equation that contain a unknown factor. Now, whenever you solve any equation, your goal is to isolate the unknown. In this case, it's a factor, or we can also call it the variable in algebra. So we want to have that unknown or variable on one side by itself. And eventually, one variable on one side, the other side is a number. We call it the answer to the equation. Now, let's demonstrate this process using the example below. So now we have the first equation, x times 16 equals 208. In algebra, usually we use a dot to indicate multiplication. We don't use this cross. The reason is it's very confusing if you also have x in it. People don't know which one is multiplication, which one is x. So we use a dot to indicate multiplication. Now our goal is to have x by itself, so that the other side is number, we call it answer, right? How to get rid of 16? So in solving equation, whenever you want to get rid of something, you want to do the opposite operation. So x and 16 are connected by multiplication. We want to disconnect them from here. So what is the opposite operation of multiplication? That's division. That's why we want to divide by 16, because we want to get rid of 16. We don't want to get rid of x. So whenever you do something to equation, you have to do it on both sides. See, hopefully this makes sense to you. 16 divided by 16 is 1. So x times 1 is x. So we're going to get 1x. That's our goal. That's why you want to divide by the number that with x. That's why we call it unknown factor, because it's to multiply together in the multiplication. Each number is called a factor. Now let's perform this division, long division here, 208 divided by 16. And there's 116 in 20, so put 1 in here. And the remainder is 4. Put down this 8, 48. There are exactly 3 16ths in 48. So divided evenly. So our answer is the quotient is 13. Now we solve this equation. It said solve and check. Again, how do you check if your answer to an equation is correct answer? All you need is plug in this number back into the equation to see if both sides of the equation equal. So x is 13. We do 13 times 16. We want to know if this result equals 208 or not. If they're not equal, my answer is wrong. If they're equal, my answer is right. So let's just check 13 times 16. 13 times 16. What do we get? We get 208. So that's exactly right. So checked. So 13 is our correct answer. Let's move on to the next one. And we have 2 more example questions here. And this is kind of similar to the previous one, but we have 0 on the right-hand side. So what do we do to solve for n? Our goal remains the same. We want to have this n on one side by itself, right? So we need to get rid of 14. So we do opposite operation again. This is multiplication. We want to do division on both sides. 14 divided by 14 is 1. 1 times n is still n. 0 divided by 14 is 0. Our answer is 0. Let's check to see if it is correct. So plug in this n equals 0, replace n in the equation with 0. So 14 times 0 equals 0. And that equals the right-hand side number. So it's checked. So this is the answer. So this is checked. This is the correct answer. Now, the last one, we want to solve for y. So apparently we need to get rid of 0. The connection in between is the multiplication. We want to do the opposite operation, which is division. And we cannot divide by 0. We already mentioned this. When you divide by 0, is equivalent to you want to divide 5 into 0 part. And that cannot be done because 0 part doesn't have meaning in it. We can divide things into 2 parts, 3 parts, 1 part, but it cannot be 0 part. So this one cannot be done. What that means cannot be done? That means no solution. It means that no solution. There shouldn't be gap in here. No solution. And you get some exercise problems here and solve these equations, 4 of those. Now let's look at our last topic for this video. We want to solve some application problems involving division. That means during the process solving to answer questions, you're going to use division. Let's look at this example. And this is the last example for this video. An egg farmer has 4,394 eggs to distribute into packages of a dozen each. So they are going to put all these eggs into those packages. Each package will have a dozen eggs in it. How many packages can the farmer make? How many eggs will be left? Now, imagine you have all of these eggs. You put them into dozen egg packages. Say let's imagine this is a 1 dozen egg package. This is another package. This is another package. This is another package. So each package will contain 12 eggs in it. That means every 12 egg will be one package. If you have another 12 eggs, you have another package, another 12, another package, another 12, another package. So this essentially becomes the question, how many 12s are in this whole thing? Because each 12 is equivalent to one package. It's just a matter of how many 12s are in this number. Still remember the meaning of division? Let me remind you. So if you divide 10 by 2, you get a 5. What does that mean? It means there are 5 2s in 10. So we want to know how many 12s are in this number. How many 2s in 10? So in this case, we divide by 2. In this case, we need to divide by 12. Because division answers this question, how many of divisor are in the previous number, so the first number. So these are divisor because we want to know how many 12s are in this number. So 4,394 divided by 12. So that's our answer. We just need to do the calculation. Let's do the long division. 4,394 divided by 12. There's no 12 in 4. So move to one digit to the right. And there's 3 12 in 43. 4 will make it 48, which is too big. So that's 3. 3 times 12, 36. Remainder is 7, 13. Borrowed one, 13 minus 6 is 7, 79. And if we use a 5, it's going to be 60. Use a 6, it's going to be 72. 6 is good. So 72, do subtraction, the remainder of 7, and that's 4. We do another 6 because it's 72, really close to 74. 72. Now remainder is 2. So they can put all these eggs into 366 packages and still have 2 eggs left. So the answer is, this is an application problem. Usually we need to answer the question in a formal way. And the farmer can make 366 packages, and there are 2 eggs left. And that's our answer. Let's do a quick check to see if it is right or not. So basis division gives us 366 with a remainder of 2, right? We did one of this check. We multiply these 2 numbers together and add remainder. It should be equal to the first number to be correct. So let's do that. 366 times 12, then plus 2 equals 4,394. 4,394. We get the correct answer. Now, next page is your lab exercise problem for this video. Yeah. Make comments below the video, and you may also ask questions. See you in the next video.